Okay, so we will continue the solid bodies center of mass. Solid bodies. For example, listen one thing. If suppose this is a ring, right? So where is the center of mass of this ring? Can you tell me? The ring of radius are yes at the center. But if I cut if this ring in the two parts like this is the semicircular ring. Semicircular ring. So where is the center of mass? Do you know? To our right. So although there are so many different bodies and you have to remember, but for few bodies we can find the center of mass, right, for this type of the solid body. So although the 2r upon pi we know, but we will try to derive this semicircular ring. The radius is r and the mass is m, suppose. Is it clear? So how to find the center of mass? Listen one thing. We will put this semicircular ring on the x-axis, y-axis symmetrically, so that from observation that the center of mass will lie. This is the left half part. This is the right half part. The center of mass will be lie over here. Although you know the value 2r upon pi is there, right? But how to find this? You tell. I will take an element. And small element, this is the small element of with dx, right? The angle is d theta, the mass is dm. Are you getting or not? In this case, the xcm will be 0, only the ycm you have to find, right? And what is the formula for ycm? You tell. Y dm integration of dm. Is it clear or not? So I will convert this solid body into small point masses. Right. So if I choose an element of mass dm at angle theta and d theta or with d theta like this, so this is the y, suppose. Sin theta is equal to y perpendicular upon hypotenuse. This is what? This is the radius. So can I write like this? So the value of y is what? Say r sin theta. Is it clear? And what is the value of dm? What is the value of dm? Can you tell? Yes, I can tell. The dm mass, this is a circular ring and the mass is distributed over the line. So this is the linear mass distribution. How to find the m? Using the unitary method. What is the total length of this? Can you tell? What is the total length of this? Say pi r. Pi r mass is m. So for 1 meter mass, the mass is m by pi r. Is it clear or not? For this dx meter length, mass is m upon pi r into dx. So this is the value of the dm, m upon pi r into dx. Is it clear or not? Yes. Now, what is the relation between d theta and dx? Angle is equal to arc upon radius. So dx is equal to what? Say r d theta. Is it clear or not? So the dm mass may be written as m upon pi r into dx is equal to what? Say r d theta. So dm is m upon pi into d theta is equal to dm. Is it clear or not? Right. So I will put the value of y over here. This is the r sin theta and dm is m upon pi into d theta divided by m upon pi d theta. Is it clear or not? So m upon pi will cancel out because it is constant. The r is what? Is constant. It will come out from the integration, right? So it is sin theta d theta from theta. Is it clear? The elements are starting from where? The element starts from here. This is the element. This is the element. This is the element. This is the element. Element. So these elements start from theta is equal to 0 to pi. We will add all the elements, right? So 0 to pi and 0 to pi. What is the integration of sin theta? Minus cos theta from 0 to pi, and this is the theta from 0 to pi. So you will simplify this. Minus cos pi, right? Minus plus cos 0 divided by pi minus 0. So cos pi value is -1 So minus minus plus 1 upon pi. So this is the 2r upon pi is the YCM. So this is the value of the center of mass YCM is equal to 2r upon pi. What does it mean? It means if you consider the ring, right? So the radius is r, center of mass will be 2r upon at distance. So this is the circular arc and the circular disc it is. So for the complete semicircular disc, if you put the theta is equal to pi by 2 and here the pi by 2. If theta is equal to what? Say pi by 2. So it becomes circular ring. So r sine pi by 2 upon pi by 2. So it becomes 2r upon pi. Is it clear or not? In the same way, for the semicircular disc, put theta is equal to pi by 2. So here the YCM will be equal to 2r sine pi by 2 divided by 3 into pi by 2. So this is 4r upon 3 pi. So this is the position of the center of mass of the circular disc, semicircular disc. For the semicircular ring, this is the answer, right? So you can copy. Okay, beta. For example, if I give an illustration, right? Suppose this is the semicircular this is the quarter ring it is, right, of the radius r. So here where will be the center of mass of this? Suppose this is the y-axis, this is the x-axis. Center of mass will be symmetrically lying at this point. So you have to find the coordinate of the center of mass for this case. What is the theta over here? What is the theta over here? The theta, this is the same, yes, 45. This is the pi by 4. So this distance will be equal to what? This distance r. This is r sine theta upon theta. So r sine pi by 4 divided by pi by 4. So it is 4r upon pi into 1 by root 2. It is equal to 2 root 2 r upon pi. So this is the distance of the center of mass from origin. But if we want to find this the x coordinate and this the y coordinate, right? So if this is r, this is theta. So x is equal to what? R cos theta. And what is the y? R sin theta, right? And what is the value of r? 2 root 2 r upon pi into cos 45 pi by 4. In the same way, it is 2 root 2 r upon pi into cos pi by into sin pi by 4, right? Sin pi by 4. So pi by 4 value is 1 by root 2, it will cancel out. So 2r upon pi and 2r upon pi. Is it clear or not? It is very much similar to the center of mass of the semicircular disc. Obviously, listen one thing. If you complete this disc, suppose if you complete this disc, so the center of mass will be over here. Are you getting or not? If the disc was, if the ring was, semicircular ring was completed, the center of mass will be a distance. If you consider this is the object, this is the another object, so its center of mass will be over there. Then for this disc, for this ring, the center of mass this, and for this ring the center of mass will be there. So when you combine this, the center of mass will be shifted. Is it clear or not? What distance? Say 2r upon pi. Are you getting or not? So this distance must be equal to 2r upon pi. So which is coming? Also by symmetric, this distance must be 2r upon pi. If you remove this portion, now if you consider the complete semicircular disc, the center of mass will be in between 2r upon pi at distance this. If you remove this portion, right, the center of mass will just shift to this position, which is of this right quarter ring. So at distance r. So this remains 2r upon pi as it is. Only just it is shifted to the left, right. Is it clear or not? So this distance comes to be the x and y coordinate comes to be 2r upon pi. Is it clear or not? Copy this. So please make the correction. The holocone, okay, holocone's center of mass is at h by 3 and this is at h by 4, right? It is at less distance, small distance h by 3, h by 4. Is it clear or not? So this is the center of mass of this body. Suppose we have the sector similar. Suppose this is the circular semicircular disc, right? If this is the semicircular disk, what is the center of mass? You tell. 4r upon 3 pi. Is it clear or not? Semicircular disk. Semicircular disk. Right? Semicircular disk. So you tell me, if I just remove the first part, the half part this side. So the center of mass will be shifted to this point. Are you getting or not? Right? And the center of mass will be at this symmetric line 45 degree or not. This is the same. Although you can use this or by symmetry also. If this is 4r upon pi, the center of mass will be shifted at this point or not this point. If you just remove, the center of mass will shift to this point. Are you getting or not? So this distance of the center of mass remains same. So it is 4r upon 3 pi, but it is 45 degree. So it is also the 4r upon 3 pi. So it must be the 4r upon 3 pi. Although the axiom is equal to, for the center of mass of this quarter disk, axiom is equal to 4r upon 3 pi, YCM is equal to 4r upon 3 pi. You can do in this way, but with the formula also, if you apply the formula, this formula, you can find also with the help of this formula. Is it clear or not? How? If this is pi by 4, this is pi by 4, this is r. So what is the distance r? The r is 2r sine theta upon 3 theta, and theta is equal to what? Say pi by 4. 2r sine pi by 4 upon 3 pi by 4. Right? So it is 8 sine pi by 4, and this is how much? This is 8r upon 3 pi 1 by root 2. It is 4 root 2 r upon 3 pi. This is the r. So what is the x? The x value is r cos 45. So r is 4 root 2 r upon 3 pi. And what is the value of 45 into 1 by root 2? It will cancel out. So axiom is equal to 4r upon 3 pi. And similarly, the y can also be found r sine 45, which is equal to 4r upon 3 pi. Is it clear or not? So you can use either this formula, right? Or directly by symmetry, you can write the answer. Is it clear? Copy this. So these are the two important questions. By symmetry also you can solve this question, or by formula also you can solve this question, right? There are two ways to solve this question, right? Okay, so I will give you one more example for the solid body center of mass. For example, suppose this is a solid cone, right? This is the solid cone. The height is h, right, and the radius is r. And over there, a solid hemisphere of the same material is made. Are you getting or not? So if this is the cone, right, the ice cream like this, softy you can say. So from here, this is the midline, right? You have to find that its hemisphere radius is r, and this is equal to 4r. So with respect to point O, you have to find, with respect to point O, find position of center of mass. Position of center of mass, right? Have you done this question earlier? Right, please copy this, copy this. This is the solid hemisphere on the top and the solid cone in the downward, right? This is the shape. Copy this first.
Yes. Okay. So how to solve this question? Listen one thing. It is very much clear that the center of mass from the symmetry of the shape of the body will lies on this axis. I'm making it once again. Right. Suppose this is the solid cone. Right. And this is the hemisphere. With respect to this, we have to find the center of mass. Are you getting or not? So the the question in the question it is given, they are made of same material. They are made of same material. Same material. Same material mean their density is same. Density is same. Is it clear or not? So if this is the solid hemisphere, its center of mass will be over here. Suppose this is the mass m1 and this is the solid cone. Its center of mass will be m2, will be there. Are you getting or not? First, can you tell me this distance and this distance? Yes, we can find this distance. What is the, for the solid cone, for the solid hemisphere, what is this position? Can you tell? 3r, 3r by 8. So, since this is the radius, so this is 3r by 8, no doubt. And what is this distance? If this is h, which is equal to 4r given, what is the position of the center of mass of solid cone? Say h by 4. So this is h by 4 and this is equal to 4r by 4. So this distance is r. The center of mass 1, center of mass 1. This is the solid body. Now we have to find the center of mass of this combined system. Is it clear or not? So the x coordinate no doubt is 0. The xcm is 0. Only the ycm we have to find. So what will you write the ycm? Say ycm is m1y1 plus m2y2 divided by m1 plus m2. Is it clear or not? To find, you can replace this solid body with the its m2 center of mass position, right? cm2, cm1. Now before applying that formula, the m1 is what? The mass of the solid hemisphere. What is that? Mass is equal to volume into density. So what is the volume of this? The volume is 4 upon the volume of the sphere is, what is the volume? 4 upon 3 pi r cube. This is 2 by 3 pi r cube into density. What is the volume of this cone? What is the volume of this cone? 1 upon 3 pi r square h. Is it clear or not? So this is the volume V2, 1 upon 3 pi r square. What is the h? What is the h? Say h is 4r. Is it clear or not? Right? So this is equal to 4 upon 3 pi r cube. 4 by 3 pi r cube. This is 4 by 3 pi r cube into rho. Is it clear or not? You tell. The formula of the cone volume is correct. The h we have put it correct. Now to make the calculation simple, right? You can put this value is m naught, right? So then this m2 value will be what? It is 2 by 3, it is 4 by 3. If I assume this is m naught, then what will be this value? Sit 2m naught. So it makes calculation simple. So now I will put the value. If this is the m1, this is the y1. So m1 is m naught and y1 is what? Say 3r by 8. Is it clear or not? Plus, what is the m2? Say 2m2. What the value of y2 I will put? Please tell. What is the value of y2? Say minus r. It is very important. X1, what is its coordinate? It is 3r by 0 comma 3r by 8. Its coordinate is 0 comma minus r. So you have to take with negative sign, otherwise the answer will be wrong, right? So this is equal to 3 by 8 minus 2, right? You have to add. So 3 minus 16 upon 8, so minus 13 upon 8. So in the denominator it is 3m naught, in the numerator 13 by 8 m naught r. If you calculate, it will cancel out. So minus 13 by 24 R. So this is the YCM. With respect to origin, we have found, right? So center of mass of this body, suppose this is the cone plus solid sphere. The center of mass will lie right down below the x-axis. What is the distance of 13 upon 24 R? Is it clear or not? Copy this. This is the one important question. This type of question given in your sheet I have seen, right? So I will give you the homework. Okay, now we move to the next topic in the solid body center of mass, and this is the truncated body, right? It is important, right? Center of mass of truncated body. Truncated body, what does it mean? I will explain this. Suppose there is a body, it is solid body. Are you getting or not? So if its center of mass is over here, all right, so initially the position vector of the center of mass is r vector, and this is the m of the mass, right? Now if you cut some portion, right, and this is the m cut, suppose this is the mass which is cut or truncated from the solid body. So will the center of mass will be on the same position? No, the center of mass will be shifted the this position. This is the cm, right? So this is the r vector of remaining, right? Remaining portion. This is the rcm, right? This is the r vector of the remaining portion, cm dash. Is it clear or not? If it was before it is cut, then the remaining portion center of mass position vector is this with respect to origin. Also, suppose this is the m cut value and this is the body which is cut out from this solid body. Its center of mass is m cut, right? And which was cut, which is removed from this, its position vector is r cut. Are you getting or not? So how to write the remaining portion? Remaining portion center of mass position is m1. Suppose this is the initial m1 r1, right? Or you just write it is m and r minus m cut r cut vector divided by m minus m cut, right? So this is the position vector of, this is what? Position vector of center of mass of remaining portion. Remaining portion. Is it clear or not? So this, how to apply this formula, I will give few examples, then you can better understand this. Just copy this. If you have any doubt, you can ask. Please copy this. So for to understand this formula, I will give you example. This is the JEE previous year 2021 questions. What is the question? Suppose we have the disk, right? We have the disk and the radius of the disk is what? Say A. Are you getting or not? Suppose its surface mass density or the surface mass density is sigma. Are you getting? You understand or not? Surface mass density kg per meter square. It means for 1 meter square the mass is sigma kg. This is the meaning of the surface mass density. Now you tell me, if I consider without cut, the mass is m, right? So what will be the mass? So its mass will be equal to sigma into pi a square, first of all. And where will be the center of mass before cut? The center of mass before cut will be or the origin, and its position will, its mass will be m. Now in the second figure, I have cut in this question a disk of the radius a by 2. Are you getting or not? So now this is the remaining portion. Are you getting or not? This is the remaining portion. So obviously it is very much clear that the center of mass will be shifted to this point. Are you getting or not? This disk is cut out. So this is the m cut which is cut from here. The radius is a by 2. Are you getting or not? Can you tell me what is the mass of m cut? Yes, I can. Sigma into area. Sigma into area. What is the area of this disk? Can you tell me? The radius is a by 2. It is pi r square. a by 2 whole square. Sigma pi square by 4 is the m cut. You understand this thing or not? So if I assume the initial mass is m naught, so the m cut will be written as m naught by 4. This is the way of calculation. It makes simple. Are you getting or not? So the m cut we have found, only the r cut. If this is the origin, this is the center of mass of the cutting object. So its m cut will be present over there. So what the r cut you will write? You tell. What is the r cut position vector? This is in this side. So this is a by 2. You tell me this thing you are getting or not. So the r remaining. What is the formula? Say m into r minus m cut into r cut divided by m minus m cut. Is it clear or not? Hello? Yes, Varsha. The m is m. Listen one thing. What is the r? The r is the position vector with respect to origin before cut. So what is the r? Can you tell? This center of mass is at the origin. So before cut, the center of mass at the origin. So what is the value of the r? You will tell. Say r is equal to 0. So here, what is the m? M initial before cut is mass was m naught, but the position vector was at origin, minus what is the m cut? It is m naught by 4. And what is the r cut? R cut means this is the vector divided by m naught minus m naught by 4. Is it clear or not? Now you will simplify this. It is m naught a by 8 divided by 3m naught by 4. Right? So what the answer you will get? Minus a by 6 it is. So the center of mass will be shifted to this point by distance a by 6. Is it clear or not, you tell? So this is the solution of this question. Copy this. Okay, so this is the next question which was asked in the JEE 2020. That's very much similar. It is a disk. So before cutting, the surface mass density sigma kilogram per meter square, I will assume. This is the mass m and the radius vector is 0 before cut. Right? Now, if you cut a disc, if you cut a square shape hole, is it clear or not? This is cut. So the center of mass of the remaining portion definitely will be shifted to this by symmetry. Right? So if this is the m cut, right, this is the square. So what is its side? Say a by 2. Or what will be the m cut? Can you tell me? What will be its m cut? Is equal to sigma into its mass will be equal to sigma into pi a square, no doubt. Sigma into area. What is the area of this square? You tell. This is the a by 2 whole square, sigma a square by 4. Is it clear or not? So listen, if sigma a square I assume to be sigma a square assumed to be the m naught, so it become pi m naught, so it become m naught by 4. For the calculation, simple. Are you getting or not how to solve this? So this is the m cut. Now what is the r cut? It is the center of mass. A curve distance d by from center O. So what is the distance? I think this is the r cut is given. R cut is equal to d, and this is equal to a by 2. This is not very much clear, but as shown in figure, this is the center of mass. Yes, it is a by 2. Are you getting or not? Yes, Varshaz. This is a by 2. So what the formula I will apply? The r remaining is equal to what? m1 r1 minus m cut r cut divided by m minus m cut. So what is the m? The initial mass is pi m naught, right? Minus pi m naught minus what is the m cut? Say m naught by 4. What is m? It is m naught into 0 minus m naught by 4, m naught by 4 into what is the r cut? Say a by 2. Is it clear? So it is m naught a by 8 divided by m naught common pi minus 1 by 4. It will cancel out minus a upon 8, 4 pi minus 1 upon 4. So it is minus 2a upon 2 minus 4 pi minus 1. So it should be the answer. Nearest integer they are asking, nearest integer. So this is the r remaining is equal to what? Say minus a upon 2, 4 pi minus 1. So nearest integer we have to find 4 into 3.14, right? 4 चौक 16, 4 एकम 4 और 1 5, 4 तिया 12 माइनस 1, तो 11.56 इंटू 2, 6 दूनी 12, 5 दूनी 10 और 1 11, हाँसी लग गया 1, 2 एकम 2, 3 2, 23. So minus a upon 23.12. So the x value is nearest integer is 23. Now it should be the answer. Copy this. For truncated body, little tough question, right? On the basis of the volume chart, volume mass density. For example, suppose we have a solid sphere of radius r. It is. Is it clear or not? Now from this, a sphere of radius r by 4 is cut as shown in figure. What is the figure? Listen, initially it is like this. So now from this figure a solid sphere is cut. Are you getting or not? Like this. This is the solid sphere, right? Solid sphere is cut. What is the radius? Say r by 4. This is the center of mass. Now the center of mass will be shifted to this point. Now find new position of center of mass. Is it clear or not? It is a from this a sphere. This is the solid sphere I am writing here. Solid sphere of radius r, mass m, right? Or bus sphere of radius r, that's it. So this is the question. Copy this first, right? So now we can solve this question. Okay, so this is the solid sphere. For the solid sphere, it is made of the material. I will assume the density. We have to assume the volume mass density. The volume mass density is rho kilogram per meter cube. If it was the disk, the sigma kilogram per meter square. If it was the rod, the lambda kg per meter. Is it clear or not? So before cut, the mass was m. So m was what? 4 upon 3 pi r cube into rho. Is it clear or not? You tell. And before cut, the center of mass at the origin. If I assume this is the y-axis, this is the x-axis. So what is the r vector before cut? It is 0. Is it clear or not? You tell. Right. This is the sphere. It is cut out from the solid body. What is the m cut? Can you find? Yes. The m cut is nothing but volume into density. 4 upon 3 pi r cube. What is the r? R by 4 whole cube into rho. So this is 4 chok 64. 4 upon 3 pi r cube into rho. Is it clear or not? You tell. This is the m cut. Right? So if I assume this is to be the m naught, so the m cut will be equal to what? M naught by 64. So it makes simple calculation. Is it clear or not? You tell. From here, can you tell me what will be the r cut? Please tell. What is the r cut? This is the distance of the, yes, r minus r by 4. It is 3r by 4. Is it clear or not? So now we can apply the very basic formula. What is that? This is r remaining is equal to m, this is m naught, right, into 0 minus m cut, m naught by 64, right, into r cut, it is 3r by 4, divided by m naught minus m naught by 64, right. So it will be m naught upon 3r by 4, and this is 63 m naught. By making simple calculation, 64 will cancel out. So this is minus 3 upon 463 r, and this is equal to 3 दूनी 6, 3 एकम 3, 84 it is, right? So this is the center of mass of remaining portion minus r by 84. So the center of mass will be shifted to this position. This is the cm dash. If this is the cm, this is the cm dash. R upon 84 distance it will cover, displaced. Is it clear? Copy this.